Today I'm going to go over the video from our community post. Sorry, it's been a little while. I was recording the video to answer this question about a week ago, and then there was a power outage right in the middle of my recording. And then I had to go to work and didn't get a chance to make it. And then I went out of town, and then we got hit by this hurricane, which made it a little difficult for me to record. So what I wanted to do is go over the answer to the question here on the Whirlpool direct drive washer. Washer works in a regular heavy cycle, but when it starts to drain in the permanent press cycle, the motor starts clicking and turning on and off rapidly, then stops after a minute. What could it be? So it's one of the key things we have to look for is it works okay in a heavy cycle, but in a permanent press, that's when it's giving us a problem, when it starts to drain and then go into the spin cycle, which is what happens after it drains. So I have the schematic here I'd like to bring up. Here's a timer chart here and the console of a direct drive washer. Here at the beginning, it's where the normal cycle will begin, and then it ends right here where it goes off. So this distance where the 18 is to the off position is the distance here to the off position here. So everything within this time frame right here, and I'll just go ahead and highlight that for you. Anything in that time frame, and that would be the beginning of the cycle here, which would be the beginning here, and then drain would be here, and right about here is where we would drain, where the rinse and spin cycle just begins, which is like right here. And then the final drain and spin high, which is right here, the final drain and spin high. Now the permanent press cycle starts here and ends here, which is from here down to down here. So what we're looking for is why does it work okay in normal, but in permanent press it gives us a problem. And here you can say they call it casual, but they put permanent press underneath. And here's the permanent press cycle here in the chart. So what we're looking for is when it drains and spins, and the first drain is here in the normal cycle. And if we looked here for the drain, these switches are what are closed in the timer, and the machine's going to drain on high and spin on high. So here we got, if we follow this up, this got the high speed in the motor, we got the spin cycle, and bypass. So those are the switches that are closed in the timer during the normal cycle, and we say that works. So let's look at the timer chart and see what's different between that cycle. And if we look down here on the drain, it drains on high just like the first one, but when it goes to spin, the spin cycle's low, which is right about here. So right here, this switch closes and this switch opens. So if we look at the top here, this switch is closed and this one is closed the whole time. The difference is this one right here, which is the low speed in our motor. So what we could deduce from that is that the motor's working on the high speed, the timer's advancing, doing everything in the cycle, but when we go in a permanent press cycle and it starts to drain, the motor's working okay until after about a minute or so, it starts cutting in and out. You're wondering, well, what changes? And the changes between switch number 5 and 6 in the timer. So let's go ahead and look at the timer chart here. If we close switch number 5, power goes through the blue high-speed winding to start the motor, and it comes down here through switch number 14 for spin and drain to start the motor. And this is the cycle that the motor gets during the normal wash. Okay, that's fine. We know that that works. We know here that this timer switch is good, and the motor's good on the high speed, and the start winding's good, and the motor does everything it's supposed to do in the high cycle. But what's different in the permanent press cycle? So if we go here, let me just change the color of my my pen, which I don't see the color here. My map here is giving me a little problem. But if we go through switch number 6 instead of switch number 5, let me just erase this. If we go through switch number 6 instead of 5, Notice here the centrifugal switch sends power down to the high-speed winding in the motor, and then it goes back through the switch and then through the same start winding. So we knew that those two windings here in the motor were good, and that the motor was working fine in the normal cycle. And to start the motor on a 2-speed motor like this, and a reversible motor as well, they always have to start in the high speed. What changes is this centrifugal switch right here, orange to violet. Once the motor gets up to speed, this contact closes and the motor, almost like a car, shifts from high speed into low speed. So once that motor starts draining out and it shifts from the high speed to the low speed, as the timer advances, we are closing this centrifugal switch orange to violet and the low speed in the motor. If either one of those failed, the motor would work when it's down here on the high speed, but when it wanted to shift and go through the low speed, the motor is going to cut out because the winding's no good, or this centrifugal switch here is not closing to send power to that winding. And in that case, the motor dies. So when the motor dies, then it goes back to the high speed and the start winding and starts up again. So this would happen on and off, like the motor would start, stop, start, stop, start, stop. And after a few times of it doing it, especially with water in the tub, it's going to overheat and it's going to cut off on the overload, which is internal in the motor. And that's why the complaint says that the motor cuts in and out and then it finally stops after about a minute. By that time your motor's overheated, it started on high, shifted to low, didn't work, went back to high to start, died, went back to low, and it just kept switching back and forth. This problem was a problem they used in the Skills USA problem back in 1993. In that year, one of my students was competing at a national contest, and that was the problem that they had in the washer. Everything worked, and when it got to that cycle, it would try to switch into low speed, and the low speed wouldn't work. So we either have a bad centrifugal switch or a bad low speed winding. So the answer is one of those two components were at fault, and that would have been right. So if anybody selected low speed winding or centrifugal switch orange to violet not closing, then they would have got the correct answer.